Dr. Chuck, the science schmuck.
Oh, wow, is it ever warm in here? Warm and stinky. The Winogradskys have finally winograded to an extent. So they're kind of in reverse order here. Freshwater, seawater, hypersaline water. Now, you can't perceive time exactly now, but you can probably notice that all the foam fell off my wall because it got warm. And I was informed it doesn't actually do anything. And also it is warm when it was formerly cold. The issue being that this took forever to run. It's been like 6 months. The main problem being that's how long it takes for it to go from cold to warm here. It's probably about 80, 85 degrees in here, which is about the temperature I prefer to be in. These actually start reacting when it gets warm. At the cold, the response is very slow. So of them, you'll notice that there is a distinct color difference. The freshwater has begun to develop green on the top, and the desired outcome, reddish on the bottom. Since that's not readily available through that camera, I'll use this camera on my phone, and then hopefully figure out a way to switch between 1 and 2 to kind of give you an impression of what this actually looks like. And if, okay, that looks like it turned on. Okay, that looks like it turned on. I'm now watching and being watched. So look, there you is. Camera on a stick. Now, that's the green layer on top. On the part up here, I've actually had to oil these with vegetable oil, which was a mistake, and we'll get to that in a second. So, this is a green layer of something photosynthetic. In theory, there's not oxygen here, so this is either, considering it's this close to the top, my guess would be there's a strong potential that it's photosynthetic bacteria. The question is whether they're like cyanobacteria or green sulfur bacteria. Black stuff is usually an indication of how to phrase it, hydrogen sulfide producing bacteria. The black is metal sulfides that form with trace metals in the media. Turning it, this is the side that faces the sun. These are photosynthetic purple bacteria that cannot exist in oxygen and use hydrogen sulfide as a source rather than, or some sort of sulfur as a source rather than carbon dioxide as you would see in actual green plants. And then this is probably a little bit of a mixture of the two. Oh, lost focus there for a second. So that is actually developing the bacterial types I want. And it looks like it's also generating something up there. Look at that. That looks nice, doesn't it? Very bubbly. And again, we'll get to that in a second. This is like seawater level. That's probably iron, which is the same that you're seeing in there, because it has been dissolving the nails in it somehow, because there's nails in the center of these. This one is notable in that it has only achieved this thin line of brownish colored stuff. I don't know what that is, but there's no purple bacteria or green bacteria growing in this sample. That leaves the question, are we seeing that these bacteria prefer fresh water, as in here, and not salt? Well, the way to confirm that is to, let's take a look again. Yeah, that's pretty gross looking. Again, to check hypersaline. So this is much saltier than normal water, with sea salt, or synthetic sea salt in this case, and the amount of black stuff in that water is impressively black. It's very dusty too. Let me wipe that off for a second so you can see what this looks like. The water, the liquid phase, has become pure black with I don't know what, which continues to grow inside this sand. There's no signs of the photosynthetic bacteria as in the freshwater, indicating that they probably don't grow as well in the saline situations, especially in the hypersaline situation. And that this is probably a result of, there's a leak. That's something I don't want to touch. This is probably a result of just regular fermentation. You can also see that in the freshwater, there's all these void spaces, which I had periodically removed. That's gas leading up and escaping. There are void spaces in the saline ones, but not nearly as much as you would expect. Sort of mud area on the bottom is relatively unchanged. So that would mean that what we expect to see is the bacteria I want and that are useful occur. Ooh, it's gurgling. The bacteria I want occur in freshwater. Saltwater, there is an anaerobic process, and it's not pretty. How do I know there's an anaerobic process? And that's ultimately the issue that you can't discern from just pure visual data. The smell. The abominable, atrocious, and terrible aroma of all of this. So I put oil on top of these just because they became unparalleledly stinky. It's fermenting gelatin, and dirt, and mud, and coffee, and a bunch of other ingredients. It releases hydrogen sulfide in a variety of organic compounds that you don't want to smell. They don't smell good. And it's been escaping into this room, filling it up with just this smell that is, well, smell-o-vision never really caught on after it was invented, but to describe it to you, it is similar to a diaper. Like, if you had an older diaper that was in like a bag and kind of pungent, but not hit you in the face pungent. Actually, I can experiment with this right now. These have oil on them, so a lot of the gas is caught there, but they still do release hydrogen sulfide and other gases. So not enough to kill me. Hydrogen sulfide is very lethal, but enough to smell. This one smells like wood, like fresh cut wood in like a farm. Like there's some manure there, but it's kind of distant. It's a little bit sawdusty, like a petting zoo. Like, ooh, that smells like animals, but not terrible. Middle saline. Much sharper, still the same basic scent of like wood and farm, but then like this sharp like acid, like almost like a vinegar, but not quite as distinct as vinegar, just sort of acid. Much lower in note. It's much more of a diapery scent. And that's with the oil on them. This room stinks because these stink. I don't mind this one stinking because it looks pretty, but these two have now been determined to be very smelly, and this whole place is smelly. And even though that black stuff is pretty cool, this one is the one I want to be the source for what I'll be moving on with probably the rest of this video, or if this video takes too long, I'll do a part 2. I'll split it. So I need to disassemble these, because they're too smelly, and they've figured out the experiment. Hypersaline doesn't, neither of the saline grows well, this green and purple stuff. Hypersaline makes black water. I don't want to know what the black water is exactly. It smells bad, and it's kind of poisoning me. I feel a little nauseous. I thought for a second that they had put eggs in my, my chicken patties, which doesn't really make sense because they're chicken, and chickens aren't made of eggs, except they are, but not in that way. So apparently I can't eat eggs anymore, because they make me very sick. And aside from that TMI, why did I not disassemble this Winogradsky? Because it had the effect I want, namely the production of red and green sulfur bacteria. Future version of myself, flash a picture of it on the screen now. Hopefully I remembered to do that, or listen to myself. I don't know, I feel like I'm the kind of person who would not listen to myself, giving myself orders. And I would end up doing something very self-destructive, like eating eggs. I know they make me sick. So, what happens is that in the Winogradsky column, it's hard to see on this camera, but you saw the picture, the production of sulfur on the lower levels rises and diffuses through here, coming out as purified stink, and produces bacteria and algae that exist through it. So that red stuff, that's not algae. It's bacteria, a type of bacteria that doesn't exist in an oxygen atmosphere that performs photosynthesis using light, in this case sunlight from my window, as you would expect. But instead of processing carbon dioxide into sugar, as you would expect normal photosynthesis to do, like in this random plant, which we'll get to later, it processes hydrogen sulfide and other sulfur gases into energy using an entirely different pathway. So it lives on sulfur, it dies in oxygen, it's almost everywhere. Turns out the main source of it is dirt, It is commonly found in dirt. I originally found a great deal of it in this plant, which is some grass, water grass or reeds. I have dubbed it Winogradsky. It grows in the anaerobic layer of this stuff, and then I put some in there, and it took off like a rocket, namely because it's hot in here, which probably is also not helping the stink situation. It grows well. So, as I stated somewhere at some time, I want to turn this little Winogradsky in its adorable little vase, which will probably still remain. I'm only going to use it as a source of some bacteria for a much bigger Winogradsky. Better? Probably not. But also to be more interesting than to just produce color gradients. Now, the vessel that I have chosen for this is a vase. Big surprise. Smells bad inside. And that's how you communicate with whales, and that's why no whales will talk to me. This is a much larger glass vase. So this grass vase will be holding grass in a vase. And then I'm going to turn it into a larger Winogradsky column. And not in the way you're thinking, which you're thinking 2 steps ahead of me, so get back in line where I am. I don't want to turn this into just a giant version of this where it's just filled up with media and just has this stuff in it. I want more visualization capacity. What I want to do is have a similar material to this in the lower level. Then I want to have a space to visualize the texture of the water and behavior of the water, and if anything is moving around in just the water. Then another layer, similar to that sand, which will be an oxygenic layer. This green stuff on top might be oxygenic, but I don't think so, because there's oil on top of here to prevent moisture from getting out. Well, it's to prevent stink from getting out. It doesn't work. So I've actually got better oil, that's vegetable oil, but now I've got colorless mineral spirits, which will help with that when I reconstitute that. But in this case, there will be a whole level up here where I can grow plants and such, and I can finally produce my dream in the last 2 inches of having a tiny ecosystem with little animals and such, namely shrimp and stuff. Tiny shrimp, not real shrimp. Don't get your hopes up. So the first thing I need to do is, in a technical sense, I need to make the slosh. Which is a technical term because I just said it, and I just said it was technical. So you have to believe me because I'm a doctor. I'm not a doctor. And if I was, doctors don't make up words unless they're doctors of linguistics? What is the word that means words but sounds like the word that means bugs? I don't know. I'm not going to look it up. So what is the slosh made of in this case? Well, a few things. I have a bowl. The first ingredient is some ordinary dirt, which is exactly as the name describes. It's dirt with paper. It's what I use in place of potting soil and also where I dispose of banana peels that often I have ground into a fine pulp, which doesn't smell as good as you would think it does. That provides organic matter in a pretty simplistic way, but also its own innate, interesting bacteria. In terms of this one, I don't want to break down the plant entirely, so I know this contains the bacteria I want. So what I'm going to do is I'm going to add some water from my water pitcher. And you can see there's green, probably sulfur bacteria in the bottom, as well as red. Oop, spilling everywhere. So I want to get the bubbles out, and then I want to decant that a few times, just to get some of them in. Yes. Proceeding according to plan. Of course, since it is a Winogradsky column, it needs a source of sulfur, and I have used several things. I've used magnesium sulfate, which I ate. That caused its own problems. Do not eat that when you have, like, a frozen intestine, because you will back up, and it will come out the top. Unflavored gel, aka unflavored gelatin, will provide a protein source, which is probably why these smell like exploded animals. I had a rod. Aha. That provides a protein source, also a sulfur source, because of probably trace amounts of cysteine. Yeah. It's collagen. I don't know how much cysteine's in collagen. I could look that up. Because I know how to look that up, but I'm not going to right now. Now, I don't want to disrupt this too much because it's so pretty. So what I'm going to do is add water. So, mix the top layer a little. Ugh. Now, there is a lot of vegetable oil there, so that's going to be unfortunate when it gets in the mixture. Drippy. The reddish stuff on the top is not Winogradsky materials. It is iron produced from decomposing nails in way deep in the solution. Which does make me wonder. It's not good. Not as bad as you would think. It smells kind of like really rank dirt. And then, just to keep out oxygen, because that has worked so well before, I'm going to use colorless mineral spirits instead of vegetable oil. Because those won't decay as the vegetable oil did. And that will help keep out oxygen to keep the nice anaerobic reactions going. That's fine. It can now go back on my shelf and continue to do what it does, and be stinky. Now I will apply the slosh into the column. Now, since I have bad aim, I need to wash the walls of the column on the inside with this water. And then sand, similar to the current one, for visualization purposes. Already a black layer of organic matter in there. Now, for the interesting part. In order to add a shelf, I have previously created one. What is it? Well, it's a stick. The idea of this is that it's a stick, which I found outside from a branch. I cut it. I then put some nails through the side to give it reinforcement, and put it in concrete inside this used Keurig-type cup. So now that is a weighted area to keep it from floating away, and also to anchor it. So that's the anchor. This top part is made of oatmeal lids, which I have nailed to the stick, and also applied with hot glue a crossbar to help support it. This has holes drilled in it, which will allow for gas exchange, as well as a very slow exchange of liquid, but not sand or material or roots falling through very readily. So the idea is to center that, and then just push it down. Well, okay. A little bit of a modification, but I have taken about 2 inches out of this and shortened it by cutting it in half. There is actually a metal rod in there that is glued in place, and then gluing the two sides together. It's not a high stress situation, but it'll hold in terms of compression, in theory. It just needs to not wobble. So now, then push it down to the center. Now, those of you who are observant, who have very high resolution monitors, will notice, well, no you won't, because my camera can't notice, it doesn't fill the entire diameter of the situation here. Which is why I also have this. It is a hole, well, it is several holes, put into the lid of a peanut butter can, of which I ate all the peanut butter out of. An interesting thing is that when you try to drill them, it just shatters because it's relatively brittle. So I took a nail, heated it up, and just stabbed it with a hot nail to produce those. Those are melt holes. That mostly just reinforces it so that it doesn't go anywhere. Now, on top of that, add an additional layer, some pea gravel, in the same peanut butter can of which I ate the peanut butter out. a nice protective gravel layer. Some of it's going to fall down to the bottom, but that will allow for gas to go up and out, and the sand, when I add it, to not go all the way down and through. Well, that's a problem. The sand is going through. Perhaps I did not think this all the way through. Okay, I think I may have come to a solution. I reset the thing, poured out the gravel, poured out everything. And I have put around that red thing, the red lid, scrap canvas from a drop cloth, which will hopefully be compressible enough with the rocks to prevent sand from falling through. Additionally, since the sand was poured out, it is now pre-wetted and has rocks in it, but that's just the way it goes at this point. Okay, let's clear out the void space by adding water. Well, okay, it seems to be holding, and that we now have an anaerobic production chamber down here at the bottom, which has all that slosh and the gelatin, which I guess some of the gelatin's now up here, so this is going to do its own thing. This is down here. This is another sand layer up here. We have water in between for observational purposes. Don't know what that's going to turn into, if it's going to stay black, or if whatever's turning it black is going to eventually precipitate out and begin to decay. Gas may evolve up through that. It doesn't evolve down. Gas usually doesn't go down in water. And then up top in this more rocky layer, I can plant small plants, which will be the next phase of the project, after I go take a break and wash my hands. Well, it's a little difficult to see it from where your perspective is. Why am I greasy? I'm still greasy. I don't think I will ever be ungreased. But it's begun to settle on the bottom, clarifying slightly, in an area that will eventually become fully anaerobic. And I have found some plants from various sources, which I'm going to put in the top section. Namely, these. So what do I have? Well, firstly, I have some actually flowering red Ludwigia sprigs from the paludarium experiment. I only took some of them because the others are actively flowering, so these are a semi-terrestrial plant that lives in swampier waters that can develop an extensive root system and grow out of the top of the container. This is some sort of hydrilla? I think it's an invasive species, but it's pondweed that I found in a local river. This is a different type of pondweed from the same river. This is just ordinary grass. It was growing in the paludarium, so I'm going to stick it in here and see what it does. And then this grass, I'm going to try to get some of it out. This stuff grows poorly in this little pot, but has grown pretty successfully in the paludarium, which has the same species. And then, this. It looks gross right now, because it kind of is, because I just received them. This was from a different project, one that I'm not actually broadcasting because it's relatively mundane. But I grow plants. I grow a lot of plants. This is a somewhat depleted water hyacinth, which is a floating plant. Inflate with water. And then the last two aspects I need to give are one, this. This is a jar containing two types of floating plants. There's Salvinia and Azolla, which are both species of very small floating ferns. We're getting a little full. So I want to empty this, but I don't want to spill it, so this is going to be the grossest possible way to get it out. I got a piece of airline tubing. And there you go. The trick with a siphon when you're using it is don't suck too hard, or whatever you're sucking goes in your mouth. More than once I've had to drink the paludarium. It's probably why I can no longer eat eggs. I got poisoned by paludarium water. It's not nearly as healthy as you would think. Especially when, you know, it's this stuff. Remove that. However, there was something in here of note that I wanted, but it's in the bottom. Pond snails. That's where this comes in. This is a combination of various waters. Oh, wow. My goal of this water was to provide material that contains biological material drawn from the paludarium, as well as the other ongoing project, which is basically I'm just growing some plants and potentially some triops if they would stop dying. There we go. And hopefully the editing will cover this in transition. What is in the water right now? All those little white things? I mean, you can see there's some pond snails going around doing snail things, but all that stuff, what in the world is it? Now, the answer is it's something alive, and something that is very abundant in this water. But I have no idea what it is. That's a much clearer view. Yeah. So there's a lot of something living in that jar. I'm glad I didn't try to drink that jar, because who knows what those would do to me. They seem to like organic matter, so they'll be right at home in here. Those are some sort of organism. My guess would be water fleas, Daphnia, I don't know, some sort of tiny crustacean, some sort of tiny worm. They're not triops. Regardless, where they're going is to get mixed up, and they're going in here. So there are two basic behaviors I expect in the upper part, which looks messy now, because it's just sort of plants thrown in there, but once they actually start growing, if they start growing, then it will become abundant. So the top part of this Winogradsky column has both water and plants that are out of the water. Plants that sit out of the water consume material from the water, namely water itself, plus non-water things such as dissolved nutrients. They don't contribute oxygen. A plant that sticks out is absorbing oxygen from the environment, which means it can grow potentially faster because it doesn't have to worry about solubility and all that. A plant that lives in the water is actively pulling materials out of the water entirely. So all of its carbon dioxide comes from the water, oxygen produced flows into the water. So the presence of these plants, some floating, some submerged, will produce oxygen. Oxygen in this realm will probably diffuse somewhere down to here and provide a layer of bacteria that are capable of using oxygen to support their life. Going below that, you know, down here, who knows? At that point, you're starting to not be able to reach the oxygen. Plant roots might get that far, and they may provide oxygen somehow. But generally, it'll just sort of sit there. Sulfur will come up from the bottom, in theory, because that's this decay area here, down on the other side of this water, which, as the carbon sources in here, which is a combination of dirt, peat, moss, gelatin, and general muck, as it is digested, it will consume all oxygen in this realm. This realm will be devoid of oxygen, like a cave. Any organisms that tread there will either have to be able to not use oxygen, or they will die, and other organisms that don't use oxygen will eat them. Now, whether or not these areas converge will be the question. This will produce sulfurous gases, hydrogen sulfide, which will rise up through the system, potentially, whereas this area will produce oxygen, which may sink through the system. So we'll get to visualize the gradients in much greater detail between these two realms in an actual ecosystem versus the deep muck, which can be hundreds of meters deep underneath the swamp. So I've created a swamp in a jar. This is pretty cool looking. It'll make a nice sort of display figure in my corner next to the window. But I might put it up higher, like on a desk, so that I can look in and see all the little tiny organisms swimming around. Hopefully no organisms that get bigger than what I put in there, but that's always a possibility. Anyway, it looks super cool, so I consider this to be a start of what may very well be a success. But we'll wait on that and see how it turns out. And that doesn't make a sound anymore. Concludes this project. So,
Well, it concludes the start of this project. So end.